Okay, so Dr. J here, and I'm here with Block 5. Okay, so Block 5, say hi. Everybody's there. Okay, take my word for it. And what we're going to do is we're going to go ahead and go through all of the problems that we saw on our chapter review. Okay, every single problem we're going to do right here, right now, because you guys are reviewing for today's rhymes with biz and starts with a Q. Yeah, today's quiz. Okay, I'll tell you about that in a little bit. Okay, it's a low stakes quiz. All right, if you miss problems, you will get to do quiz corrections. You can still earn full credit. Okay, so it'll be all right. Now let's go ahead and take a look at these problems. Okay, so our first problem was problem number 1 here. Okay, number 1. And so we're going to take a look at problem number 1 first. Okay, number 1. And let me change this to red because I think it'll look better. It's going to be open notes. Yes, open notes quiz. Okay, so an airplane rolls down the runway compared to which reference point is the airplane in motion? Okay, so the key term here is reference point, right? What does reference point mean? What does reference point mean? What's the key thing, Daniel? What now? Yeah, reference point means not moving. So the only thing here that's not moving is the control tower. So the correct answer is B, okay? The cargo is in the plane. That's no good. The pilot is in the plane and the wing is attached to the plane. And we know that the airplane is rolling. So those other points cannot be reference points relative to the plane, okay? Number 2, we did not look at. So we're going to take a look now at number 3, okay? So which represents the greatest average speed? Well, we know that average speed, right, is total distance over total time. And each of these curves goes out to 30 seconds, so the total time doesn't change. The only thing that changes is total distance. Which one of the curves goes the farthest total distance? Which curve? The blue one, okay, right here. That goes the farthest. These other ones are all below, okay? They're all below the distance traveled by the blue line. So the correct answer there is A. A. Any questions, guys, about that one? Okay, we are moving and grooving right along. All right, now this one is interesting. Which describes the greatest displacement? In order to do number 4, we have to draw. So let's watch. 3 meters east, 3 meters north, then 3 meters west. Okay, that thing kind of undoes its original path. So maybe not for that one. 3 meters east, 3 meters south, and 3 meters east. Okay, that does pretty well. 3 meters north, 3 meters south, 3 meters north. That only goes 3 meters total, right? And then 3 meters north, 3 meters west, 3 meters south. So in this case, right, we've gone a total of 3 meters. In this case, we've gone a total, okay, the whole thing adds up to a total of 3 meters north, right? In this case, we've gone a total of 3 meters this way west, right? But in this case, we've gone 3 meters, 3 more meters down, and then another 3 meters west. This is the longest total displacement, okay? B is the correct answer. Any questions about that? Understanding our west from our east, from our north, from our south, that's really important for that question. Okay, now let's take a look at number 5. Number 5, which has the greatest average speed? Average speed, okay? The speed we need. So a boat sailing 80 kilometers in 2 hours, well, 80 kilometers divided by 2 hours equals 40 kilometers per hour. All right. Car driving 90 kilometers in 3 hours. Well, 90 kilometers over 3 hours equals 30 kilometers per hour. Train 120 kilometers in 3 hours. So 120 kilometers in 3 hours equals 40 kilometers per hour. Okay. And then finally, a truck 50 kilometers an hour. Okay. 50 kilometers in an hour. 50 is greater than 40 and 30 and 40. So D is the correct answer. Any questions about number 5? Okay, let's keep cruising along. So now we're looking at number 6. Okay, something is accelerating, right? So this one's tricky because this gets its centripetal acceleration. A bird flies straight from the tree to the ground without changing speed. So it's straight and it's not changing speed, no acceleration. A dog walks at a constant speed along a straight sidewalk. Again, straight and constant speed, no acceleration. A girl on a straight path, the same distance each second. So, okay, straight and constant velocity, no good, right? Now a truck around a curve without changing speed, but it's curving. That means we have centripetal acceleration. So we have centripetal acceleration for D, that is acceleration. Any questions, guys? Okay, moving on. So our boy Richard walks from his home to his school at a constant speed. It takes him 4 minutes to travel 100 meters. Which of the lines could show Richard's motion on his way to school? Okay, so he goes 100 meters in 4 minutes at a constant velocity or a constant speed. That means a constant slope. A constant slope, that's the green line, okay? That's the green line that is right here, okay? That's the only one. It's worth talking about these other ones, right? This shows 0 velocity, okay? This shows decreasing velocity, right? He's going slower over time, so this curve shows decreasing velocity. Decreasing velocity. And then this orange curve actually shows increasing velocity. Okay, that's what's going on there because the slope is increasing over time. So that person kind of started slowly and then realized, oh, I gotta hustle and get to school, right? So that's what's going on there. Okay, any questions? Let's move. Unit of acceleration. So remember, acceleration is change in velocity over change in time, right? So you're gonna have something like miles per hour per second or something like that, right? That's a good like miles per hour per second. That's a good acceleration for when you're in your car. Well, what about this situation, right? So you've got some distance over 2 units of time. Well, that's D, meters per second squared, okay? Meters per second, right? Per second, okay? So it's a change in velocity, which is measured in meters per second over time, which is also measured in seconds. So meters per second squared is what we're looking for there. Any questions, guys? Okay, let's keep rolling. We're making good time here. All right, which have the same velocity, So the important thing is that velocity has 2 components, speed and direction. Okay, speed and direction. So a boy walking east at this speed and a man walking east, so we have the same direction, but we have different speeds. So A is out, okay? A car standing still and a truck driving in a circle, right? So that's no good because this truck has a speed and the car is standing still, so that's out, okay? A dog walking west at 3 kilometers per hour and a cat walking west at 3, so look, same speed, right? Same direction. What's the deal? C, that's correct. Okay, let's just rule out D for the sake of it. West at 3, south at 3. Okay, the 3 is good. The west and the south cancel out. That's no good. D is out, B is out, C is our answer. Okay, any questions, guys? Okay, we're moving on. So number 10, we're out. Number 11, we're out. Number 12, okay? So number 12, that shows the following motion. A person leaves the starting point at a constant speed of 4 meters per second. Okay, so the person, let's just graph right here. All right, so the person leaves at 4 meters per second. I'm gonna draw this up at 40. I'm gonna draw this at 20. I'm gonna draw this, we go for 4, 2, and 4. So we're gonna go all the way out to 10. okay? And this is meters. And then this is time in seconds, okay? Time in seconds. So distance in meters, we have time in seconds. All right, so let's look at the first situation. 4 meters per second for 4 seconds. Let's multiply that out. 4 meters per second times 4 seconds. The seconds cancel out. That gives us 16 meters, okay? 16 meters. So after 4 seconds, we'll put a 4 right there. All right, this person's gone 16 meters. Well, that's right there. So first order of business right there. Now the stops for 2 seconds. Okay, so it's 6 seconds, right? This person hasn't gone any farther. So that's a flat line there. And then 2 meters per second for 4 more seconds. Okay, so we've got 2 meters per second times 4 seconds equals 8 meters. Okay, so 16 plus 8 is 24. So we're gonna put that 24 like right there. And then that finishes up the graph. Okay, that finishes the graph. Any questions? Any questions? Okay, watch the video if you've got questions. Okay, I'm going pretty quickly here. So rewatch, let me know if you've got questions. I'm gonna clear this out. Let's take a look now at 13. A truck travels at 55 kilometers in 1 hour, then for 35 kilometers for 2 hours, then 175 kilometers in 3 hours. Okay, what's his average speed? Right, so average speed, right, that's total distance over total time, right? And the total time is gonna be 3 hours plus 2 hours plus 1 hour. That's gonna be 6 hours, okay? Total distance, we've got 55 kilometers in the first hour, so we'll go 55 plus 35 for 2 hours, so 35 times 2 plus 175, okay, for 3 hours. And this is all kilometers, okay? And if you do the math, 55 plus 70 plus 175, that's gonna give you 300, okay? So you're gonna get 300 kilometers in 6 hours. That gives you 50 kilometers per hour, okay? That's your answer, 50 kilometers per hour, all right? So understanding how to read the problem and then set up the math, that's the key thing. This math is simple, but being able to set it up is crucially important for us, okay? Any questions? All right, let's move on. So let's look at number 14 here. Our buddy Keisha measured the distance her friend Morgan ran on a straight track every 2 seconds, okay? And her measurements are recorded in this table. What was Morgan's average speed? And then we're not gonna worry about the acceleration for the trip. So remember, average speed, that's total distance over total time, which in this case is just 20 meters divided by 10 seconds. So that gives us 2 meters per second, okay? Any questions, any questions? Going once, going twice? Sold for a bag of Skittles. Skittles, they're delicious. Taste the rainbow. So here we go, number 15. A friend tells you he's 30 minutes from the fountain in the middle of the city. Sorry, 30 meters from the fountain in the middle of the city. Write a short paragraph explaining why you cannot identify your friend's position from this description. Okay, the issue is that the friend could be anywhere within a 30-meter radius. So your friend could be anywhere within a circle, right? So you don't know which direction your friend is from the middle of the city. So that person could be in any one of these places, right? To be kind of, you have to walk around this whole circle to find your friend. Okay, that's the story there. All right. So that's why that's not helpful, or as helpful as it could be. 30 meters, not so bad. All right, now this was the problem that gave the most people the most difficulty. So our buddy Nora, number 16, rides a bicycle for 5 minutes on a curvy road. This is crucial. At a constant speed of 10 meters per second. Describe Nora's ride in terms of position, velocity, and acceleration. Compare the distance she rides to her displacement. Okay, so let's talk about this. So her position, Okay, it's always changing. It's not constant. Okay, her velocity, it's also changing because the road is curvy. Okay, so directional changes. All right, that's the issue. Okay, then you've got acceleration. Acceleration, okay? Because the road is curvy at constant speed, okay? That implies that you'll have, that tells you, that dictates that you'll have centripetal acceleration. You will have centripetal acceleration, okay? And then the distance compared to the displacement. So check it out, right? The distance is outlined by the red path, okay? Starts on the left, finishes on the right. The displacement is outlined by the blue path, okay? So you can see that distance is greater than displacement, okay? Distance is greater than displacement for Nora, all right? That's what's going on there. Any questions, guys? Okay, I'm gonna go ahead and erase this. We'll head to the next question. We're almost done. So 18, 19, and 20, these are pretty quick. We're gonna knock these out really quickly here, okay? So a model train moves 18 meters in 122 seconds. What's a train's average speed? You just got 18.3 meters over 122 seconds. That's approximately 0.15 meters per second. Then that's done. A car travels 45 kilometers in an hour. And the next 2 hours, it goes 78 kilometers for each hour. Okay, what's the average speed? So you've got 45 plus 2 times 78, and you've got kilometers here, divided by 3 hours. If you do all of that out, you get 67 kilometers per hour, okay? 67 kilometers per hour. Then the speed of a car traveling on a straight road increases from 63 meters per second to 75 meters per second. Okay, so we have a change in velocity in 4.2 seconds. What is the car's acceleration? So you've got 75 minus 63, and the unit is meters per second, divided by 4.2 seconds. And that's gonna give you roughly 2.9 meters per second squared, okay? Roughly 2.9 meters per second squared. All right, and I can box these other answers too. And then last order of business. A girl starts from rest and reaches a walking speed of 1.4 meters per second in 3 seconds. She walks at this speed for 6 seconds and then slows down and comes to a stop during a 10-second period. What was the girl's acceleration during each of the 3 time periods? Okay, period 1, you've got 1.4 meters per second divided by 3 seconds, which equals, right? Good grief, that's gonna be 0.47 meters per second squared, okay? That's the first one. Then for number two, you've got a stop for the same speed for 6 seconds. So it's 1.4 meters per second minus 1.4 meters per second all over 6 seconds. That equals 0 meters per second squared. She's not changing her velocity or her speed, so she's not accelerating. Okay, if there's no change in speed or velocity, there's no acceleration. All right, last order of business. 10-second periods comes down to stop, right? So it's negative 1.4 meters per second divided by 10 seconds. That's going to give us negative 0.14 meters per second squared. And it's negative because she's slowing down, right? She's going to ultimately to a speed of 0 from a speed of 1.4. So that acceleration is negative 1.4 meters per second squared. Okay, so that's the story there. All right, so we've got everything on the page here, everything's written out. If you have any questions, let me know. I'm going to put this video on YouTube right away, okay? And you can reference this video if you would like as you work on today's quiz. All right, so today you got your quiz. If there's time, okay, I'll help you with your quiz corrections. I'll get through as many people as I can. All right, and your buddies will also help you with them. And then anything that you haven't turned in from chapter 1 review, okay, turn in today. All right, that's your goal. As always, good luck and may all the forces be with you. That's right.